Hello. So we're going to have a look at mole calculations today. I'm going to split this over a couple of videos just because this is quite a big topic. Can get quite confusing, but it is one of those key fundamentals in chemistry and will really help. So we'll be doing it this week and we'll be doing it after half term as well. Now, see, quick reminder, please make sure you've not got your phones on distracting you, you've not got the TV on or playing any games in the background. You also need a pen and paper, and you will need a calculator as well, probably. Now, see, if you've got your phone, use your calculator on your phone. That will be useful. Or hunt around and try and find your calculator you use at school. So we're going to start off and we're going to have a look at what is a mole. Now I'm going to ask you to bear with me a little bit first. I know I don't normally do this, but we're just going to work through. So you might have all heard of a dozen before. A dozen is a word we use to represent the number 12. So your parents might go and say, oh, can you go and get a dozen eggs? And you'd go off and you go, yep, I'll get a dozen eggs. I'll get 12 eggs. You know that a dozen eggs means 12. And it's quite useful for people that sell eggs. So if you've ever bought eggs, you know they come in those little cardboard boxes that either contain sort of normally 6 or 12, sometimes 24. Very useful for selling eggs. So we can get a dozen is 12 eggs. If I said half a dozen, that equals 6. And we're pretty happy with that. We get that. We know that, yeah, a dozen is 12. Half a dozen, well, that's 6. If I wanted you to get 2 dozen, that would equal, how many would it equal? Yeah, that's it, 24. Because we're getting that. We're getting 24. We're getting 2 lots of 12, which is 24. And it's really useful for people that sell eggs to work in dozens. We've got other words as well. So a pair means 2. A baker's dozen is 13. A grand is 1,000. We're looking at money. A pony is 500. All things where we use words to represent a number. Now, chemists do the same thing with the word mole. So it's not that little furry creature. It is something different. Now, a mole also represents a number. It doesn't represent 1 or 2 or 3 or so forth. It's actually a very big number. It is 6.02 times 10 to the power of 23. It's a huge number. It's 6,000 and so forth. It's 23 zeros after it. Ridiculously big number. But it comes in very useful. But we'll have a little look at what it means. So if I said I want a dozen eggs, that is 12 eggs. We're pretty happy with that. If I wanted 2 dozen eggs, we'll go, okay, it's 2 dozen eggs. Or to get to that, I'm going to do 2 times 12, which equals 24 eggs. And we can do that. We go, yep, okay, I've done that in my head, potentially. You've got 2 dozen is 24. And we might say that, right, okay, let's have a look. I want 1 mole of eggs. And we'll say, how many is that? Ah, well, that is my number from here. It is 6.02 times 10 to the power of 23 eggs. If I wanted 2 moles of eggs, that would equal, we would do 2 times 6.02 times 10 to the 23. Now I can't do that in my head. I could give it a little go, but I'm going to do it on my calculator. And that would give me 1.204 times 10 to the 24 eggs. Now obviously your parents aren't going to ask you to go out and buy 1 mole of eggs. I don't think that number of eggs has ever existed in the history of chickens. So we use a mole for looking at very small things. Things like atoms and molecules. We measure those in moles. We're going to have a look at why. So we're going to look at linking moles, mass, and relative mass. To start off, I'm going to get you to do a little bit of a thought experiment. So thinking with me. So I've got a scale here, a mass balance. I've got a beaker on it, and I'm going to take 1 atom of lithium. I've just drawn it just there. It's tiny, you can just about see it. Ridiculously small, and I'm going to put it into my beaker, and my scale stays at 0 still. I'm like, well, I've definitely just put a lithium atom in. I know I have. I'm going to put another one in just to make sure. So I get another one. There it is, tiny one there. And I put it in. And it still stays at 0. And I start putting more and more in. And I put 100 in. And it's still at 0. I put 1,000 in. Still at 0. I put 1,000,000 in. Still at 0. I put millions and millions in. And gradually I start seeing an increase in the number. And I keep putting them in until I get to 7 grams. I've got 7 grams worth of lithium. There's my lithium just there. I've got 7 grams. And then I go, right, I'm going to count up all the atoms that I've put in there. All my lithium atoms. So I count them up. And 1, 2, 3, 4, 5, 6, and so forth. And I get to 6.02 times 10 to the power of 23. This is standard form. You've done this in maths. I'm not going to go through it too much. But I get that many atoms. So this many lithium atoms weighs 7 grams. And you might think, oh, that's interesting, 7 grams. I recognise that number 7 from somewhere with lithium. And we're right. Looking at the corner of my periodic table here, I've got lithium. My relative atomic mass is 7. So 1 mole, this many, 6.02 times 10 to the 23 number of lithium atoms will weigh 7 grams. If I took this many, so my 6.02 times 10 to the power 23 beryllium atoms, it would weigh 9 grams, because a beryllium atom is ever so slightly heavier than a lithium atom. But if it was sodium, it'd be 23 grams, and so on. And we're going to have a look at another one. We're going to have a look at, this time I've got H2O. I'm going to take a water molecule. Now, H2O, I know I've got an oxygen, and I've got 2 hydrogens attached to it. And I'm going to put that in. And I put it in, and I keep putting more of them in. And I get to my 6.02 times 10 to the power of 23. And at the bottom along here, I've got a little bit of water. Now I'm going to go, how much does this weigh? For this one, I haven't got water in my periodic table, but I've got to do something different. So I've got my H, 2, and I've got my O. I'm going to have to work out my relative formula mass this time. Now hydrogen, I know, is 1. It has a mass of 1. I look at my periodic table, but I've got 2 of them. 1 plus 1 plus 16, my mass of oxygen, and that will equal 18. So if I have 18 for my relative mass, and I've got this many of them, it will weigh 18 grams. I'm going to use my word mole for this bit. So my mass, which in this case will now be 18 grams, is equal to my moles. This time I've got 1 mole, because I've only used 1 mole on this bit. This is 1 mole. Times by my relative mass, or my MR, my relative mass of my molecule. In this case, it was 18. So my moles, my number of moles I have, times by my relative mass, my MR number, equals my mass. Now what would happen if I put 2 moles of water? let's have a look. So I have 2 moles of water. I'm going to use my same equation here. So my number of moles this time is now 2. My MR has stayed the same. That's 18. I'm going to do 2 times 18, and that will give me 36 grams of water. Now what if I only put 1 mole in, or half a mole in, sorry. So I would do half a mole. So I would have half times 18, and that would equal 9 grams. So we've got this equation here. My mass equals my number of moles times my relative mass. Then we're going to have a little look at working one out. So I've got my question here. What is the mass of 4.56 moles of CH4, or methane? I'm going to write my equation out so I can remember it. So my mass, that's always in grams, equals my number of moles times by my relative mass. So my mass, again, equals my number of moles, which is my number here, 4.56, times by my relative mass. I'm going to have to work this out now. So I've got CH4. So that tells me, so C is carbon. I look on the periodic table, and that is 12. My H is hydrogen. My mass of hydrogen is 1. So 12 plus 1 is 13. And I can do 4.56 times 13. That's right, I hear you shouting out, going, Mr. Lewis, you're being an absolute numpty. We've got that little 4 there as well. I'm going to go, what does that 4 mean? And, yep, that's right. I've got 4 hydrogens. So we have 4 hydrogens. So I've got 4 hydrogen here. So this 1, I've got 4 of them. So I'm going to do 1 plus 1 plus 1 plus 1. So I've now got 12 plus 1 plus 1 plus 1 plus 1 equals 16. So my equation now is 4.56, so my number of moles, times by 16. And that gives me a grand total of 72.96 grams. So 4.56 moles of methane will weigh 72.96 grams. Now, chemists are a little bit weird. Chemists don't like using it as that formula. Chemists prefer using it to work out the number of moles. So they have it slightly differently. They've rearranged it. So our mass equals our number of moles. Writing out what we know already. Times our MR. Now, chemists like doing it as number of moles equals something. I'm not going to talk about doing rearranging a linear equation. We know you can do that from maths. So chemists get it as the number of moles equals the mass divided by MR. Just divided both sides by MR. And this is how chemists will remember it. Don't ask me why they do it this way around. I prefer looking at it like this. So mass is moles times MR. I think it's a lot easier to try and remember it round that way. But this is how chemists do it. But if we can remember it one of these ways and know how to rearrange it, we can work out everything else. So we're looking in this one now. So this question here, how many moles are in 500 grams of Fe2O3, so iron oxide? So luckily, I'm going to use my equation. This one here. My moles is mass divided by MR. So I'm going to have my moles equals my mass, which is 500 grams. Easy. Divided by my MR. A little bit trickier. I need to work this out. I need my periodic table. So I have a look. So iron is 56. You're right, I have 2 of them. So it's 56 plus 56. I need to add my oxygens on. I've got oxygen, which is 16. How many have I got? That's right, I've got 3. So I'm going to add 16 plus 16 plus 16. I'm going to add them all together, and that will give me 160. So I can now work out my equation. I'm going to do 500 grams divided by 160. So my number of moles here equals 500 divided by 160. going to use a calculator because it's just so much easier. And I'm going to get 3.125 moles. So that is how we use our equation. It's how we link our mass, number of moles, and our relative mass. It's what a mole is. It is a tricky concept. These equations are not quick to do. They do take that little bit of time to do. But you now have some questions on Microsoft Forms to complete. So do them. Your teachers will go through them and check any understanding, any misconceptions, any problems you're getting, and highlight them. Otherwise, have an absolutely wonderful day. Enjoy the little bit of snow that we still have, or hopefully we've got even more now. Don't forget to subscribe to the channel if you're watching this at home. Have a great day. Take care. Bye-bye.